Okay, so I'm going to try to show you how to use a calculator to draw a graph of a piecewise defined function. Oh my, what's happening here? There we go. Something happened. So we're going to use a calculator to draw a piecewise defined function. I don't know if you know how to do this, so I thought I'd show you. I'm going to do number 16, 116, because you've got access to the answers for 115 and 117. They're clickable here. You can also go click on the link in course resources. I've got the student answer key there, and they've got pretty detailed solutions, which is nice. Not just the answers in the back of the book. If you bought a paper copy, are just the answer, and these solutions, or at least have some working with them. So how do we do a graph? How do we graph a piecewise function to evaluate a limit? So with a graphing calculator, now this is a TI graphing calculator. If you have a Casio, I don't know how to do it with the Casio. Most people have this. This is actually a good investment, folks, if you're thinking about continuing math, okay? But that I understand it's 120 bucks. So I'm sure I can do this with Desmos also. So what we do with a graphing calculator, if you have one, of course, go to y equals, and then we'll type in the equation. What am I? I'm going to do number 16. So x raised to the third. Whoops, be nice if I'm sorry, I forgot that I got to do this. I got to put it in parentheses, okay? And you'll see why in a minute. So I'm going to put x raised to the third minus 1. Close your parentheses. And then what we want to do is we only want to graph that piece when x is less than or equal to 0. So what we can do is, this is one way that I was showing how to do it that works. It's pretty easy. I'm going to divide the function I want graphed by x, and the way we get the calculator to show less than or equal to, you see that little test, the blue test over the math key? I did second blue, and you see less than or equal to? Choice 6, you either come down to it or type the 6, and then 0 is the condition we want to meet. And what that'll do, and you'll see in a minute, it's going to graph that cubic function's been shifted down 1 only when x is less than or equal to 0. Now, the other function that's part of this question is what the horizontal line y equals 1. Can't quite see it on the screen here, but it is. And I want that graphed when x is greater than 0. So 1, I don't need to worry about a parenthesis there because it'll do it, but I do need a parenthesis here. I'll do x is second test 3. Notice I'm doing an open interval here because I want this to pass the vertical line test, and if this function is defined at 2 different places at x equals 0, that's a problem. I mean, for this question, no, but it is a problem if you know, really. All right, so now what I'm gonna do, because I don't need very big windows, I'm just gonna do a zoom 4, and lo and behold, there we go. Pretty slick. Rather than graphing the whole thing, it stopped where it was supposed to. To answer the questions, what is the question? What's the limit as x approaches 0 from the left, and what's the limit as x approaches 0 from the right? So if I come back to my calculator, as I approach 0 from the left, y is approaching -1. And as I approach 0 from the right, y is approaching 1. Or actually, y is 1 in this case. Okay. So yeah, that's that. So how do we do this with Desmos? Well, with Desmos, type in the equation and then use curly brackets to make those definitions. And it's pretty, I mean, so what you're going to do is I'm going to type in x is less than or equal to. So I did shift period or shift comma and then equals, and it kicked it to an equal to, and then I'm doing 0, and then I do shift to do the greater than. What is it? It's shift period, at least on my keyboard, and we get the same graph, same results. Okay, so that's how we do piecewise defined functions using tech. Works pretty well. Maybe what I should do is tweak this just a little bit so you can see. Suppose I want to do 3 piecewise functions, and I have like a compound inequality here. What if I wanted to graph y equals 1 from 0 to 3, say? Less than or equal to 3. See, I would just graph that horizontal line from there to there. So then if I wanted to make another piece, I don't know, what if we do the absolute value of x shifted right 4? That'll be, at least it'll be connected this time. So y equals absolute value of x minus 4, is shifted right. I don't, it did some kind of subscript, didn't it? -4 shifted right. And now I want to stop graphing at x equals 3. So curly bracket x is greater than 3. And there we go. Okay, so that's how you can do a three function definition. Okay. And here the limit would be the same, so the limit exists, right? But that's not what this is asking. Okay, so hopefully this helps. Give me a yell if you need help.